Today in this class I'll solve a problem which was left undone, and the problem is this: evaluate the integral, I'll write it here, integral a r cubed dr d theta, where a is the region bounded by r is equal to 2 sine theta and r is equal to 4 sine theta. So this is the problem that I am going to solve today. I am going to do this multiple integral of this r cube dr d theta, and this is in polar coordinates. The multiple integral is in polar coordinates, and that A is the region which has come because of these two circles. Actually, these two represent the circle in polar coordinates, and here this r is equal to 2 sine theta is a circle with a radius 1, and this r is equal to 4 sine theta is a radius with radius 2, and these two bound an area over which this particular integral is evaluated. See this, I will write this how I am going to find this. So you see that r is equal to 2 sine theta. Now you put theta is equal to 0. Put theta is equal to 0. You will get r is equal to 0 because sine 0 is 0. Then theta is equal to 30 degrees. Then you get r is equal to 30 degrees means what? Or 2 into sine 30 is half, that is equal to 1. Like that you can give r is equal to, for theta is equal to 45, theta is equal to 60, and you give theta is equal to 90 degrees, for which it is sine of 90 degrees, that is equal to, so this is 2, r is equal to 2 sine 90, and that is equal to 2. And you see that after then you can go up to, see up to, you can give theta is equal to 135, 120, like that it goes on, and you can finally give theta is equal to pi, for which 2 sine 90 will be equal to 2 sine 180 degrees. So this is 2 into sine 180 is 0. So this is equal to, that is the r value of this. So you see that by giving the value for theta from 0 to pi degrees, you are able to get the full circle described. See how it is done here. See, I will draw here. See how this is drawn. I'll draw this. See. So I'll draw here. And this is 1, this is 2, 4 here. So you see that this is your 0, this is your x-axis, this is your, now you have to write r is equal to 30 degrees, r is equal to 45 degrees, and r is equal to 90 degrees. So this is 90 degrees. When r is equal to 90, you will get this point. This is nothing but what? This point is your 2 and this point is 4. That means this is your r is equal to 2 sine theta, and this is r is equal to 4 sine theta. So you see that, I will explain this again. So you see that how I am drawing this circle, r is equal to 2 sine theta, r is equal to 2 sine theta, you give theta is equal to 0, your r will be 0 at the same point here. See here, this is the point. So this is 0, 0. 0, 0, and you give r is equal to 30 degrees, you get sine theta is equal to half, so you get r is equal to 1. So you see that you are going to r is equal to 45, you will be here. When theta is equal to 45, theta is equal to 60 degrees, and when theta is equal to 90 degrees, you see that this is 90 degrees, so sine 90 will be 1, and therefore you will get 2. So for theta is equal to 90 degrees, your r value will be equal to 2, and after then if you give 120, 135 like that, it traces on the left hand side and it slowly comes down. For sine or for 180 degrees, it will come and merge with the origin, that is 0 0. That means it takes for 180 degrees, it takes the full circle, and r changes from what? It changes from 0 to 2, maximum is 2, and then comes back to 0 again. So the same thing you must apply for r is equal to 4 sine theta. So what is your r is equal to 4 sine theta? Here again you do the same thing. So here you give 0, 1, 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. So for 90, what will happen here? So for 90 degrees, so theta is equal to 90 pi by 2. Your r will be equal to sine pi by 2. Sine pi by 2 is 1. So at 4. So what will happen here? It will go to the n.4 of that. So you see that this will be the outer circle is r is equal to 4 sine theta, and inner circle is r is equal to 2 sine theta. Now you can see this, an area is enclosed in between the two circles, and this is your A. Are you able to understand? So this is your A over which we are going to do the integration. Now let me rub off this for space, getting the space. So let me do the problem now, continue doing the problem now. So I will write here, let A be equal to this. And what is your A? A is the area, region, A is region bounded by r is equal to 2 sine theta and r is equal to 4 sine theta. So this is one. Now here A is equal to what is that? Your A is this area. So you have got this area. A is bounded by theta from 0 to pi, and r is equal to 2 sine theta to 4 sine theta. Now are you able to catch what I am telling you here? So you see that here when you change this r from 0 to pi, for this it is a smaller circle, for this it is a bigger circle, but both of them will describe only will describe only circles. This inner circle is with the radius 1 and the outer circle is with the radius 2. So that is understood, and that the full circle can be described for theta taking the value from 0 to pi degrees. That means your theta takes the limit of theta is from 0 to pi, and your r value is from 2 sine theta to 4 sine theta. So once the limit of the integration is fixed, then we can evaluate the integral easily, provided we know how to do the integral. Okay. Now let me come here. So what is here that I have to write here? So let A, I will write it here, let I be equal to, so what is that I have to write here? For r, the range is from r is equal to 2 sine theta to 4 sine theta, and this is ranging from 0 to pi, and this is r cubed dr d theta. So this is what we get. Now let us see, the integration has to be done with respect to r first, then with respect to theta. So this will be equal to your 0 to pi, and this is nothing but r to the power of 4 by 4, and the integration, the limit of integration is from 2 sine theta to d theta. So this will be equal to This will be, take this 1 by 4 outside, so you will be left with 0 to pi. If you apply the first limit, for upper limit 4 sin theta, your r to the power of 4 will be 4 into 4, 16, 256 into sine to the power of 4 theta minus, it is 2 into 2, 4, 4 means 16, again sine to the power of 4 theta into d theta. So this I will write. So what is that you will get? Apply the upper limit, it is 4 sin theta whole to the power of 4 minus 2 sin theta whole to the power of 4. For 4 sin theta whole to the power of 4, you get 256 sin to the power of 4 theta. For that it is minus 16 sin to the power of 4 theta into d theta. You do the simplification here, it will be 240. See, this will be 240 divided by 4 and it is 0 to pi. It is sine to the power of 4 theta into d theta. So this will be equal to your 60 of 0 to pi sine to the power of 4 theta into theta. Now this is the integral which has to be evaluated now. Now what I am going to do is that here I am going to apply the properties of integration. What is that? I am going to apply the properties of integration in order to evaluate this integral. I will write the properties of the integral here. See, the first property I will write here, the property of the integral. Let me use, see, the property of the integral is, it is not 1 because I am going to use only one property. It is 0 to 2a f of x dx is equal to 2 times of 0 to a f of 2a minus x if f of 2a minus x is equal to x, and the integral will be 0 if f of 2a minus x is equal to minus x. So this property I am going to use here. What is the property that I am going to use here? It is integral of 0 to 2a f of x dx is equal to 2 times of 0 to a f of 2a minus x. Here dx I have to put here. See, dx if f of 2a minus x is equal to f of x and this will be equal to 0 if f of 2a minus x is equal to minus f of x. About this let us not bother here. I am not going to apply, this is not going to be applied here, or this is of no use for us here. Only this property will be used. So what is that? 0 to 2a of f of x. In the place of f of x you have got sine to the power of 4 theta, and in the place of 2a you have got 2 into pi by 2. 2 into pi by 2 is equal to pi. So it is 2a, in the place of a you have got pi by 2. So how do I identify this integral as this to apply the property? I take this a value to be pi by 2 so that I can identify this as this integral, and if I can, and you can see that, and what is that you find here, and also you find applying this sine to the power of 4 pi minus x. What is sine to the power of 4? Because I am going to apply this property. F of 2a. What is in the place of f of x here? Sine to the power of 4 theta. Now in the place of theta you put 2a, that is it is 2a minus x. In this place what is your 2a here? It is your pi minus x sine to the power of 4 pi minus x pi minus x. But what is the value of this? And this is pi minus 180 minus theta lies in the second quadrant, where sine is positive. Sine is positive and sine remains the same, and sine is positive. Moreover, sine to the power of 4 means 4 is an even number. So whatever be it, it is going to be an even function. So since it is an even function, this is nothing but again it is sine to the power of 4 6. So this property is satisfied. Now the property that f of 2a minus x is equal to f of x is satisfied. Therefore, I will be justified in writing this integral as this 2 into 0 to pi by 2, because here you see that in the place of a you have got pi by 2. So I am justified, or I am right. I am correct in writing that this integral as 2 into 0 to pi by 2 into sine to the power of 4 theta, because this property, this holds good. That is, f of 2a minus x is equal to f of x property holds good. Therefore, I can write this 0 to 2a f of x dx as 2 0 to a f of 2a minus x dx. But this value is nothing but your f of x. So, in the place of f of 2a minus x, I can write f of x again. I hope that you are able to understand. Let me apply the property, and here you see that here I will write here that, so this pi must be written as what? Your pi is nothing but what? 2 into pi by 2. So identify this pi as 2 into pi by 2 to a. So a will be equal to a pi by 2. So I can rewrite this integral as, I am going to rewrite this integral as, so what is that I am going to write here? So this can be written as, see, this can be written as, I will write this as 60 into 0 to pi by 2, because I told you that pi by 2 into 2 is pi. Therefore, this is sine to the power of 4 theta into 3 theta. So this is what I am having. Now, it is enough if I evaluate this. Now, evaluation of this integral, it requires the idea of reduction formula, and the integration of the limit of integration is from 0 to pi by 2. So you see that 0 to pi by 2, and this sine to the power of 4 theta, it requires your idea of reduction formula. I will write here, so I will write it here. So what is that I am going to use? Now we know that I will write n minus 1 divided by n, n minus 1 divided by n minus 3 divided by n minus 4. Then it goes on like this, and then half pi by 2. So this is the property. See, n minus 1 divided by n, then n minus 3 reduce it by 2, n minus 3 reduce by 4, n minus 4. So you see that it goes up to half and pi by 2, provided your n is even. Provided your n is even. Now, this, see here you can see that sine to the power of 4 theta, so 4 is an even number, so I can apply this. Now say I'll write here, so applying, see I'll write here, or I'll rewrite here, so I'll see, so applying the idea of 0 to pi by 2 sine n theta d theta is equal to n minus 1 by n minus 3 by n minus 4 up to half pi by 2 n even, we get, so applying the idea of this to 1, applying this to 1, we get, what do you get here now? So what is that you get? So this will be equal to 120 into, what is here? 4 minus 1 is 3 divided by 4. Then 4 minus 3 is 1. 4 minus 2 is 2 into pi by 2, because n is even. So what is that you get? 120 into, how much do you get here? It is, let me cancel here itself. Why should I repeat this? So you see that this goes 30 times and this goes 15 times, and this will be equal to your 45 by 2. So what is the integral of this thing? Integral of this, that is integral of r cubed dr d theta over a is equal to 45 pi divided by 2. So this is our answer for this problem.